Okay, so today we're going to be going over something called the chain rule, okay? So we went over the power rule, we went over the sum and difference rule, we went over the product rule, and we went over the quotient rule. These rules were all to find derivatives, such as if you're given the equation y in terms of x, and we need to find dy over dx, you can just apply one of these rules. So now is an important one, and that is called the chain rule. So I have an example here. It says use the chain rule to calculate the derivative. I'm sorry, that got cut off. For y equals 3 times the quantity of x minus 5. Now, I understand that you can just distribute the 3 and do the power rule, but I wanted to kind of ease you into this type of problem. Basically, you have to identify that you have a quantity or you have something substituted into something else, okay? So it's basically try to investigate a composite function is being listed, okay? And how to really decompose it so you see it as two separate functions. Now, the chain rule in Leibniz notation to find dy over dx is to do dy over du, so it's with respect to a different variable, times du, so it's the derivative of whatever that variable equals with respect to x. So you're establishing what u is in terms of x. And you multiply them together. And if you multiply them together, you can kind of see why you get dy over dx. Okay, and then we have our outside-inside rule. And our outside-inside rule is to find dy over dx. We're doing f prime of g of x, and then we multiply that by g prime of x. So you need to establish what f of x is and g of x. Okay, you have to figure out or decompose your function so you can see it as a composition of functions. This leads into the rule that we use for our next lesson, which is the power chain rule. So basically, the derivative of a function with an expression in it, we'll call that u, with respect to x, is going to be f prime of u times du over dx. So basically, you need to always multiply. Sometimes you have to repeat the power rule, you have to repeat the chain rule or the power chain rule more than once. So it's a little heads up for future problems. But essentially, you have to also establish that you do have a quantity inside of a function, like we do in our example, as easy as it looks. We have a quantity of x minus 5 into what may be a variable multiplied with 3. So I already started doing this problem, so let me finish. So for our example, we have a quantity of x minus 5 into what would be a variable multiplied by 3. So I'm establishing that x minus 5 is u, and that y is 3 times u. So if I'm doing this right here, I'm taking the derivative of y with respect to u, and that would give me, let me do that over here, dy over du to be 3. And I'm taking the derivative of u with respect to x. So derivative of u with respect to x would be 1. And I'm just multiplying them together, and I get my final answer. Yes, it's just 3. Okay, so that's by using this notation. Now we're going to do the next one. Okay, so the next one, I'm establishing what f of x is and a g of x. Because you're more common or used to seeing, hey, there's an f of x and a g of x. And perhaps g of x is plugged into an f of x. So if g of x is the x minus 5, and f of x is 3x, then this makes sense that y is f of g of x. This would give us that y is 3 times the quantity of x minus 5. So let's do what it says here to do, and this is outside-inside rule. The outside is the 3 times whatever's in the inside. So if I take the derivative of the left side of the equation, I get dy over dx. And now if I start to use this rule, and I do the derivative of the outside, I get 3, and now I have to multiply it by the derivative of the inside. So the inside is the x minus 5. Okay, but I have to take the derivative, so I'm going to emphasize this is the derivative. And if I take the derivative of x minus 5, I'm getting 1. So dy over dx becomes 3 again. Okay, and I didn't have to show my fractions or multiplying it together. But think of it as an option 1, option 2 of doing the chain rule. Okay? Okay, so I wanted more problems, and I took a picture of the worksheet that was on the computer, just so that you can get the idea of what we're doing here. So let's say we're looking at something like number 1. Okay, and we need to find dy over dx. So if I'm taking the derivative of the left side of my equation, I'm also taking the derivative of the right side of the equation. And on my right side of the equation, I have a quantity substituted into another function. Okay? So I'm going to do option 1. Okay? My quantity is u, and that is 1 minus x. And y would be u cubed. So if I do du over dx, I'm getting negative 1. And if I do dy over du, I'm getting 3u squared. So if I multiply them together, okay, I should get dy over dx. So if I multiply this together, I don't exactly get dy over dx. I need it to be in terms of x, respect to x. So I have to replace the u with 1 minus x, and that is my final answer. And this was option 1. Option 2, okay, is when I do outside inside. So if I do the outside, okay, I'm moving the 3 in front of whatever is my function and subtract 1. And this is actually called a power chain rule because we're dealing with a power. Now I'm going to multiply that with the derivative of the inside. So the inside being 1 minus x, the derivative of that is negative 1. So now to combine these together, I get negative 3 times the quantity of 1 minus x, which is what I got here from doing option 1. So it doesn't matter which option you choose to do, okay? It does work out to find dy over dx, okay? So continue on these problems, and good luck.